Thank you. It's an honor joining such esteemed companies on this stage. We are a small research faculty based in Budapest. We just celebrated our 21st birthday. Our core mission in teaching and research is to bring disciplines together: computer science, engineering, and biology. So we nominated Cytocast because they truly embody this mission, taking a deep understanding of computers and biology, looking forward, identifying and tackling a problem that is really important. It's really exciting for a university to see a research project transform into a startup led by faculty as well as former students, looking and addressing a problem that will so fundamentally shape healthcare in the coming decades: personalized medicine. And with that, I'll let the man explain.
Breaking the wall to personalized medicine. Simone Rizzetto, Cytocast.
Guten Morgen, meine Damen und Herren. I start with the questions for you. Do you know who is this guy? Someone wants to try? No one? Okay, then I will give you the answer. So it's John von Neumann, one of the most brilliant minds of the past centuries. Why am I showing you this picture? For two reasons. Well, the first one is because he's born in Budapest, like our startup. And the second one, because he invented an algorithm which was called Monte Carlo and was central for the simulations required for the Manhattan's projects. Today, we are using the same algorithms to try to simulate a human cell. Unfortunately, creating a detailed model of a cell is still impossible. That's because a cell functions thanks to an intricate network of interactions, which is impossible to replicate in a computer. But let's have a look at what happened in the past 20 years in biology and in computer science. In 2001, we sequenced for the first time a draft of the human genome, and that required years of research and a lot of efforts for multiple research institutes across the globe. Less than 20 years later, we can look at millions of cells simultaneously, and for each of them, we can sequence their entire genomes in a matter of few days. And also on the computing side, there have been a lot of progresses. We had a lot of new algorithms that could take the data generated from the biology and perform predictions that were not possible before. And with this kind of momentum, it won't take long before we will have the data and the technologies necessary to simulate a more detailed model of a cell. There is another good news, which is that even today, with the right level of approximations, we can perform predictions and simulations that can provide useful information to develop new therapies. So let me show you how Cytocast is revolutionizing drug discovery today. We start from samples obtained from the patients, and we extract molecular information that we integrate with existing knowledge to perform personalized simulations for each patient. And for instance, we can simulate billions of interactions simultaneously for each patient and each sample's data. And we identify molecular structures that are linked to the disease and how these structures vary across patients. For instance, in this example, we identified a structure that was linked with the survival rate of patients affected by liver cancer. And given we are simulating a system, we can also modify the input. For instance, we can add a drug and see how the patients are responding to the therapy. And usually it takes years or months of research, at least for wet labs experiments to perform similar predictions. But with this software, you can do this in a matter of hours. So there have been a lot of other startups, a lot of other companies in recent years trying to integrate different types of data from the biology and perform similar predictions. But most of them were kind of black box methods, where the data goes in and you don't really know how they perform the predictions. With our software, you can simulate the full cascade of events that goes from the input data to the prediction. Therefore, we provide not only predictions, but a better understanding of the mechanisms that are driving the diseases. So we are still a pre-revenue company. We established Cytocast only a few months ago, but we are planning to make our first sales early next year. And by 2023, we will start testing our solutions for personalized medicine through our partners' hospitals. Our market is the personalized medicine market, which is huge. It's now about $2 trillion, and which is about the same of the GDP of Italy, where it comes from. And differently from that, the market of personalized medicine is expected to grow to almost $3 trillion by 2022. We released a demo recently, so if you are curious to see how our cell simulations look like, you can check our website, access our demo, and explore the results. To conclude, I would like to invite you to join our quest to make personalized medicines possible through the creations of whole cells models. And thank you very much for your time, and let's treat the patients and not the statistics. And I'm happy to take any questions. Thank you.